Well, again, hello, and thank you for joining another one of the Siemens webinars. Today, we're going to get a chance to take a little deeper dive into one of our newer pieces of software, Run MyVirtual Machine, and specifically the 3D area of Run MyVirtual Machine. So we're gonna go in, kind of show you where our portfolios are kind of sitting today. And then we're going to get in and do some real working examples using the 3D piece of this piece of software. So hopefully by the end of this event, you guys will have a pretty good solid understanding of what you can do with the 3D, what it's capable of, how to use it, and then you can certainly reference it from there. So for those of you on the event here that may not know me, my name is Chris Pollock, and I manage our application center as well as get to manage a great team of business developers. And we work with all sorts of different machine tool builders and importers. So really anybody promoting the SINUMERIK control, if they need help from a sales or an operational perspective, our team has a tendency to focus on use cases, so operation or programming topics. You can certainly reach out to myself or any number of the gentlemen in my team, and we are here to help. So my contact information is there for you. Please don't hesitate to reach out. I would say probably email is the easiest way to get hold of me. Especially I tend to talk to people on all kinds of different time zones and continents. So if you need a hand, maybe start there. If you're in a bind, you can certainly try me on my cell. Before we get into the primary topic, I do want to make sure that everybody's aware of a couple key websites for us. Certainly, they're great areas where you guys can dig into a lot of the Siemens content, especially specific to operation and programming or end user type of content or material. So CNC for You is our primary landing page. The website is right there on the top of the screen. So usa.siemens.com/CNC for You. Now on CNC for You, you can find links to our webinars, specifically all of our past webinars. There's all kinds of training classes. If you use the direct link, the /CNC for You CNC webinars, it'll just go to CNC for You, but dive directly to that page. I would say, if you're looking for material, you're either, want to promote the control and you have, potentially customers that are looking to learn a little bit more about our control, or you're a user and you want to dig deeper, this is a great place to start. We kind of have a couple different formats of training, so you can get into the webinars. That's what we would consider more self-paced learning, right? So we have a whole series of different webinars. I think to date we've produced over 100 of them on different topics. But we also have training classes. So if you clicked on the training class link, we do offer online and in-person training. So the online is instructor-led. They're multi-day courses. And they really do delve pretty deep into the world of SINUMERIK. So I would say if you're looking to get up to speed, or if you have customers that want to learn more about the product, take a look, check out. We are in the process of updating our current class offering for next year. Don't know if it's gone live yet or not, so take a look at the page. If it hasn't, just keep checking back with it. It's going to be updated here shortly. And then the in-person classes are more reserved to our advanced content, but there we actually have a training facility in Elk Grove Village, Illinois, so just outside of Chicago, about 10-15 minutes from O'Hare, so it's pretty easy to get to. And if you want to get into some 5-axis content or some high-level programming, we're going to be expanding our curriculum there, service training, that all can be accessible for you at that location. So this just gives us a list or an overview of some of those in-person trainings, like the 5-axis class for argument's sake, or our dealer service classes, which are great for service and maintenance staff. In addition to our CNC for You website is the Mr. CNC YouTube channel. So if you haven't been on it, check it out. It's really where we're now storing all of our webinar content. So all of our videos are up there from the webinars, but additionally, we do a YouTube live series. We try to do one every couple months. They're a lot of fun. We create a lot of small little promotional videos or like pointed how-to videos. All that material gets pushed up on the Mr. CNC channel. So if you haven't checked it out, by all means go look at it. And if you're enjoying what you're seeing, make sure you like and share and follow the channel. The more you guys are following it and liking the content, the more they allow me to continue doing the stuff I like to do, which is talk to you guys and put this kind of material together and promote the CNCMILLING control. So this just gives you a little example of, some of the YouTube lives we do. We do a lot of collaboration with our with different technology partners, for argument's sake. Okay, so just a quick high level. Just wanted to kind of give you that little background, but now we're going to get directly into the material that we are looking to dig into. And just give me 1 second. I had something weird just pop up. Okay, so we're going to get into what we like to call the next level of the digital twin. And you guys probably hear that term digital twin all the time. For those of you that may not be that familiar with it, really what it is it's a digital representation of your physical machine tools, what we call a digital twin. And there are certainly different flavors and formats of what would be considered a twin. Certainly the closer you get to being able to predictably see the same exact behavior your machine tool would do on the floor as what you see on your PC, that would be ultimately what we would consider a twin. A lot of cases when you just do simple machine graphical simulation, but you don't know what the CNC is going to do as far as its own decisions because you don't have the brain of the CNC in the software. There's a lot of cases where the simulation you see, in your programming department or at your PC could be very different than on the floor. That is not a twin. That is maybe a cousin or a partner or a friend, but a twin would be an exact one-to-one. And that's really what we're achieving, or certainly trying to achieve, with our latest piece of software, which is MyVirtual Machine. Now, this kind of gives you a good overview of the portfolio itself. So we've had Sinutrain out for a very, very long time. A lot of you, certainly anybody that's not new to this format, has seen me demo Sinutrain and use it as a training tool and a demonstration tool for quite a long time. Sinutrain is not going anywhere. Sinutrain will continue to be sold and supported to support our 828 and our 840 controls. However, we have recently released, within the last couple of years, our latest flagship control, which is what we call the SINUMERIK 1. And the SINUMERIK 1 is now supported by MyVirtual Machine. Now, I referred to as MyVirtual Machine. We actually have two flavors of it, Run and Create. Very similar. Run is more intended for the end user to just drive his machine around and drive the control around. Create is a little more for the guys that want to modify the machine and modify its behavior, but fundamentally they work the same way. Now, when we get to this MyVirtual Machine software, we do offer it in two flavors. We have the Operate version, which you see as the second tile there from the left, and that is extremely similar to what we had in Sinutrain. Right, so it's going to give you the HMI, right, the screen and all the keys and functions, potentially custom screens that maybe an OEM created. You get your machine control panel, which you see there towards the bottom, but that's where it kind of stops. It's fully capable and designed to support the SINUMERIK 1 control. It does go beyond the capabilities of Sinutrain, primarily because the one difference between MyVirtual Machine and Sinutrain is how we behave with the system's PLC. So the PLC is that little piece of software running in the background that makes your machine behave the way it's going to behave. Whether it's the tool changer functionality or turning your coolant on or turning chip conveyors on, that's all handled within the PLC. Now in Sinutrain, we had internally, we had a default kind of watered down, very simplified PLC. So when we created a digital twin of your system, which we could do in Sinutrain, it was a mimic or a twin of the NC side of the control, so all the machine parameters and its optimization and how fast it's going to move. But when it came to simulating the PLC, we could not do that. It was a fixed PLC. My virtual machine is using the actual PLC of the machine, so it's just that much further along in creating a digital twin. Now, the next step or the next level is we can add in a 3D option, and this we never really had in Sinutrain. This is a separate machine space model that we can drive around, move around in space. So now not only can we get an idea of what the motion path is going to look like from the HMI side, but we can now see a physical machine body moving around and then import and set up our job. And that's really the key difference of what we couldn't do in the past. We did have some collision avoidance. We could show some basic machine motion in Sinutrain, but when it came to importing vices and tool holders and different work clamps and stock models, we couldn't do any of that. Now you can do all of that in the 3D side. And that's certainly what we're going to be demoing today and digging into today. Now, for our advanced users, we do also offer the ability of embedding this type of functionality, this digital twin, right into the CAM system. So currently we do this with NX. So if you're running NX and you want to have a complete digital twin that's actually being driven by the sinumeric control, which would be our what we call our virtual NC kernel. So the behavior, the movement that I see in the model is exact to what I'll see on the floor. We can do that with run my virtual machine, VNCK, and that then rides with inside of NX. But today we're going to look at the 3D option of the software. So that is what we're going to take a peek at. We're going to look at the template machines, we're going to build some things, we're going to bring in some vices and show you functionally how it works. Okay, so in Sinutrain back in the day, we had an interface screen we referred to as our workbench, and there you could have a bunch of different machines, and it's similar to what you're seeing here on the screen. Really, the difference is that with Sinutrain, I got those little like icons and I hit the little play button and it launched the machine. In my virtual machine, we're going to get a list of the different machines. So I have a SINUMERIK 3 test you see there, or the track machines, or the DMU 50, right, or the Fryer machine. Those are all machines I can launch, and then I can run the digital twin. So that's going to work really the same way as you're used to inside of Sinutrain. Additionally, just like in Sinutrain, we had template machines. So we're going to have templates here. Now the difference with our templates in my virtual machine is it's also got the 3D model piece of it. So what we're going to do is we're going to collectively go in, we're going to create a new machine, and once we create the machine, we're going to get a chance to see all the different template files that are available for us. So we can build a simple 3-axis, which is what we're going to do today, but we can create 4-axis machine, that's the 3+1. We can create a 3+2 machine, full 5-axis. We even have some lathes built into this. So you can pick that model. Once we pick the model, we're going to come in, we're going to start to create the machine. Now I can go in and I can change the name, make it whatever I want. I click the create project, and then it's going to bring up this little initial splash screen. And this would be where I would go in and set the resolution or the size of the HMI, the screen that I'm going to see representing the machine tool control screen. We also can select the machine control panel, and this is a little different. So in the past, I had a fixed machine control panel. In my virtual machine, I can actually choose different machine control panels, and then I can even customize the machine control panel. So it gives us a lot more flexibility to make the software really look like the actual machine tool. So we choose the appropriate resolution. Now when it comes to the machine control panel, you would need to match that with your PLC you're running in the software. So in the template machines, you have to use the 483, either milling or turning. But if you're bringing in a custom machine, or if you're creating a machine, if you're at that level, then you can choose them. We'll show you the different machine control panels just so you can get an idea of what they look like. All right, once we get this all set, there's a little green cycle start button. It's going to be in the top right corner of our screen. By selecting the green button, it's going to launch it. And this is what it's going to look like once we fire up the software. We're going to have this nice machine model on our right side, the HMI on our left, as well as the machine control panel. And then from there, we'll talk about how to move the different windows around and how to kind of interface with the product. I do see people are plugging in questions. By all means, keep the questions firing. I will answer your questions at the end of the presentation. We'll have some time, we'll get to talk, and certainly you guys can ask more additional questions. So keep firing them in. I'm not ignoring you, just going to reserve them at the end. Okay, so hit the wrong button, fire up. So I happen to have already launched the software. So this is that workbench, like I was mentioning, list of some example machines. So I've obviously been playing with a few different templates, preparing for the event today. So you have three core buttons on the left. The open project is for me to get to this initial open window where I have a bunch of machines I can select. And then once I've picked it, I'm going to either hit boot or open. Boot will run right to the actual launching of the full system. Open lets me get to that splash screen where I can change resolutions and whatnot. New project would be if I'm building one from scratch, which in this case, we're not going to go through that right now. We'll reserve that for a later event. And then create project from template is my template library. So when you click on it, it's going to bring up this sub screen. Now, if I have multiple versions installed, just like I could do with Sinutrain, for argument's sake, I will see the different software versions on the right side. Now, for those of you that are new to CNCMILLING 1, the software version terminology did change a little bit, where we were in the 4-point series in the traditional operate systems like the 828 and 40. Now in CNCMILLING 1, we started in 6. So 6.15 is our current release software version, Service Pack 1, Hotfix 3, and that would be what we're going to work in today. Now with this, we have a bunch of different machine types, and for us, we're going to work on a simple 3-axis mill. But if I wanted to work on a 5-axis, you have one here. It's an AC table-table kinematic. We have some turning machines. We have a simple 3+2 AC, a basic 4-axis with an A. So pick any of them, give it some name. So I'm going to call mine SINUMERIK 3, and we'll call this our webinar machine, anything you want to call it. From there, just simply hit create project, and it's going to now start to build this machine for us. And once it initially pops up, this is that first screen I was mentioning you're going to see. This would be where I can change the resolution of my HMI. That's going to pop into this window. Now, for this demonstration purpose, I want to give us as much space on the 3D side as I can. So I'm going to keep my screen small. Normally, I would probably kick up to like the 1024 by 768 at least to give me a little more real estate in the HMI. But we're going to leave it at 800 by 480, which is the smallest res. Now, the machine control panels, they can be toggled here. So as you see, I jump from milling to turning. It updates some of the keypad, a little more specific to a turning machine. We have a MMP machine control panel, and then we get to our new MCP series machine control panels, the 1500s through all the way up to the 2400s. Now, any of these additional panels, you got to make sure that your PLC is supporting it. Some of the cool new features we're coming out with, we have these new power ride overrides. If you haven't heard of that, I will be looking to add one to my machine because I'd like to do a YouTube live showcasing the power ride. This is a pretty cool feature. It lights up, it buzzes, it gives you a feedback. It'll vibrate for you. You can use it as a cycle start and feed hold as well as an override. So that's kind of cool. But this would be a representation of one of the newer machine control panels. So for us, this PLC out of the box is written for the 483 milling. So we're going to choose that. Also, it was the default one. So if you're not sure, just leave it at whatever one is defaulted. Once we have this screen set up, hit your switch power on cycle start button, and that will start to boot up the actual control. So you'll see the HMI is going to pop up first. Once the HMI pops up, then the machine's going to start to load and it's going to pull in here. So generally, how long this takes, one is going to be dependent on the size of the file. Now, if you're familiar with Sinutrain, we used to refer to these files as set files, right? And this was the unique file that kind of traveled with the machine. In MyVirtual Machine, they're now called VCP files. Same concept, just a different extension, a little different formatting. And the VCP file is what you could then take if this was all customized and made the way I want it, and it could be emailed out and sent to somebody. So the bigger that VCP file is, the longer this tends to take to power up. I would say on an average VCP file like this one, it's probably 30 megabytes, maybe 40 megabytes, not too big. So then you're up, right? I got a nice machine here on my side we're going to talk about. It is fully driven by our software, our HMI side, so I can fire things up and I can start jogging and moving around the machine. I can certainly run part programs, do setups, all the stuff we're going to talk about today. So we're going to get into that right now, but this is fully interlocked. And this is really kind of the big difference between Sinutrain and MyVirtual Machine is Sinutrain, I couldn't have a 3D model up all the time that I could see moving around, especially when I was in jog. We could use the collision avoidance model in auto, but I had to change screens. Here, not only do I have it in jog, but as you're going to see, I can now mimic entire setups and validate my entire setup process in the software before I ever push anything down to the floor. And really that's what's key here, right? I want to be able to use this tool to validate my process. I want to make sure that my fixture is going to fit. I'm going to have enough travel in the machine. I don't have an issue with my post processor. All the things that would stop us from keeping that machine running on the floor, I want to catch that, and I want to catch that here in this environment before we ever get down. I want to keep that spindle running as much as possible before I stop it to switch over jobs, right? That is the goal. Okay, so let's get back to our slides. So we've created our machine. Now we're going to talk about kind of managing the software a little bit. So each of the windows you saw can be moved around, can be undocked. I'll be honest, a lot of times when I'm just working on my own, I'll take the 3D and put that on my second screen. Gives me a lot more real estate. So you can move them around. But as you move them around, if you want to redock them, that's where this kind of little cube comes in. So you're going to see I'm going to move the panel, and then one of these little boxes will light up. That's telling me where it's going to dock. So for argument's sake, I could take this machine control panel you see here and bring it over and hover it on the lower section. That would say it's going to dock it directly below this window. If I moved it down to the center one, it would then dock it below both windows. So that's how you can start to move around these panels. Now it's real easy when you're first getting used to this, where you can kind of get it all goofed up and you got panels all over the place and one's underlying the other and you just can't quite figure it all out. So we got a quick, simple recovery process. You come over here, there's this little, looks like slider bar, it's a little icon. By clicking it, it gives you this pop-up, and a couple things we can do here, but the big thing is a reset layout, and that'll reset our windows and kind of put everything back. So to show you, right at the top of each window, you have the gray bar, right? Kind of labels the window. If you grab it, I hold down my left mouse and start to drag, you can see I can pull it and start to move it around. And now you get those little boxes. So if I wanted the 3D sitting below in between these two panels, I could unclick, and now I just put the 3D under there. Or maybe I want to take the machine control panel and I want to move it to the right side. So I'm not going to use that right, because that'll just put it to the right of that small window. But I want to use this one that puts it to the right of the other one. So you can start to move these things anywhere you want. Again, I could take it and I could put it on another screen. Now it's totally gone, right? I can bring it back. But if I get it all goofed up like now, where did everything go? Just hit your little sliders, click on the reset button. It's going to put everything back. Now, to go back to the previous screen, you got to hit this little NC icon above. And you're going to see, now I'm back to a normal layout. Now, what it does do is it not only brings back the standard layout, but it also brings back some screens that I had hidden. So there are a lot more screens when you start to work with this software than just the 3. And that's managed by this little icon in the upper right-hand corner. So I can get component statuses. SINUMERIK operate is my control, my HMI. I can get an NCU status window, PLC IO. I can be firing IO and monitoring the IO. It's really cool. What you need by default, the minimums would be your operate, your machine control panel, and your 3D simulation. Everything else can initially go away. So that's a quick way to turn those windows off. And now I'm back to the original state. I can also grab the windows, move them over. So I'm going to bring this all the way so you get the largest 3D at this point. So that's how I start to manage the windows. Now from there, bring it back. The next area is how I kind of pan and zoom. You see me moving around the object. Well, it's pretty straightforward. The left button is going to be pan on your mouse. So if you hold down that mouse key, you can move around your mouse and it'll pan up and down, left to right. If I want to zoom, it's going to be the wheel. So scroll in, scroll out, spin your wheel forward and back, and you'll zoom in and out. And then the rotate is with the right. So you hold the right and you move your mouse around and it'll rotate. Currently, we do not support a 3D mouse yet, but I'm pushing real hard. So hopefully we're going to get a 3D mouse in this as well. I think we will in the not so distant future. But for as of now, it's super easy. Just right mouse click, rotate around, and manipulating through any of these 3. It's pretty. If any of you guys have done anything with CAD systems or CAM systems, it's pretty much the same exact gestures you're already used to in moving things around. Now, additionally, we give you some hotkeys, and the hotkeys are super helpful, especially when I get to scenarios where I want to, bring a tool down close to the part, and I want it, dead center. Sometimes it's hard to rotate the object, and you're looking at it perfectly straight. So your numerical buttons, whether you use your number pad on the right or your numbers across the top, will give us different straight perspectives. So side views, front views, back views. Now, the naming here, like one being the side view, this all has to do with how the model was laid when it was created. So it's possible that your model gives you a different view when you hit number 1. That has to do with how it was built spatially when the commissioning engineer set this whole thing up. But the big thing is you're going to figure out quickly which of the buttons you want to get to, right? 4 is a good one, right? It's going to get me right to the front of this machine model. If I want to do it from the side, then I'm probably going to want to use 3, right? And that's going to pop it around. Another one that's real handy, there are a few extra hotkeys like panning and whatnot, but the other one that I like to use is the M and the N buttons, and that's zoom as well. So instead of using the wheel, if you wanted to do a quick zoom, you could toggle your M and your N and that'll zoom in or out. So to try that, here, again, that's my left button is being held down and I can pan around. I let go of the left mouse button. I can zoom in or out with my wheel. I hold my right mouse button down and now I am rotating. And it rotates, you see you get a little black dot. So that's the point at which we're rotating about. So at the time when I kind of put my mouse down, I can control the point of rotation. So usually, I like to make sure I put it right down on the object, makes it a little easier to manipulate it around. Now, you can do zoom and rotate at the same time, but you can't do pan and rotate. So only one of the mouse buttons down at a time, but you can hold it down and zoom while I'm panning, or so you can kind of fool around with that. Or you can certainly use the hotkeys. Now, those numerical hotkeys, right? That's going to let me kind of flip this thing around and get to different set positions without having to try to get there with my mouse. So play with those. Find the one that's going to work for your specific machine. This machine, 3 and 4 are my kind of my go-tos when I'm trying to maneuver around. It keeps me from trying to get there with my mouse. That gets a little tricky, right? Come on. There we go. Okay, now the software itself, there's a bunch of extra functions within the 3D area that I do have to learn. There's the machine area. This is kind of what we've been experiencing up till now. You also have your library and your collisions area. And then there is also a settings function. To get this bar that you're seeing across the top to pop up, you got to hit the minimize or maximize icon. So that is always visible, and it's always in the upper right hand proximate corner of the 3D display. And by toggling that, it's going to pull up that toolbar across the top, and then the bottom that may change depending on which of these areas you're in. So when I'm in machine, I'm going to get some perspective of the machine tool, and it's also where I'll use to set up and load different work holdings and whatnot. When I go to library, those are all my predefined or pre-created setups. And in the library can be vices, can be workpiece blanks, can be tool holders. Now the collision area, that's going to show me whatever collisions have occurred, and it's going to create a library. And then from there, you can kind of clear them as you go. You know, you're starting a new job, you don't want to see any of the old collisions from something else you were testing, you can hit a little clear list. And then finally, if you need it, you can hit the little gear and get to the settings area. So once we come into here, then we can kind of play around with the software a little bit. So when we're a machine, I can now use this little round icon to then turn on or off different features. Right, we can create with like a layers list. So I can turn on the housing. This one only really has one. I can turn on my housing on or off, but I also have my active work offset. And that's that little round datum you see. So if I want to see where the current 0 is in relation to machine 0, that would be showing me kind of where that 0 currently is in space. And then you can move your 0 around, whatever the active one is, in that little bullseye or datum display will move around in space. Now, for us, we're going to start to play around with the software a little bit. What we want to do is we want to come in and we want to take a look at some pre-loaded examples. So from here, it's going to allow us to actually go in and physically set up an example that's already been defined. It's a great way to start playing around with the software. They gave us 3 nice examples here, all programmed and set up. So let's take a look at that first. Once we get an idea and a little bit more of a feel of how the software works, then we're going to go and create an entire one from scratch. But there are a few steps we'll have to do before this. So as I mentioned, I wanted to get the toolbar up first. So that's what this minimize, maximize area. So by clicking on it, you see it just moves the little minimize, maximize down, and that allows me to turn on the toolbar, and I can toggle between machine, library, any collisions. Now in this case, this machine was brand new. We haven't made it collide. Let's say for argument's sake, I make a collide. Now I may want to get a better visual, I may want to hide the sheet metal, and now I can see just the frame of the machine. The sheet metal can be toggled on or off, just like the little UCS display. So let's say I jog it, and I'm going to just bury this sucker down in. So it comes down, hits, goes red. We come up. Here I can even kind of come over. Obviously I got nothing on the screen, but we'll make it do a couple collisions, all right? So every time it first, as I get close, you can see it goes orange. See if I can get close. There you go, goes orange. So now I'm within a safety distance. So it's warning you that you're getting close. And now I jog in a little bit more. Eventually it goes red. So all of those are being recorded in the collision screen. So you see how you have little time stamps. Now what's neat is I can pick any one of them, and when I double click on it, as long as I'm on view, it's going to give me the image. It took a snapshot of the image of where I was at that point in time. So if I'm looking at some collision and it's, a half-inch end mill is clipping the side of my vise, I can, and I missed it when I was running the job, because we don't stop. This is not collision avoidance like it would be in the machine. This is collision detection. So we want to let this thing run all the way through the program and just capture where these collisions occurred. So here I can just kind of go into any one of them. Obviously there's only a few here. Double click on that one, right? There's the one in the middle. You can also see what parts collided. So this is handy, right? When I'm on this collision, this one that happened at 1435, it was my Y slide and my Z slide collided. And also what state was it in? Was I in auto mode? Was I in jog? So there's quite a bit of information that you can find in this little collision window. And you can toggle between these 3 different views. Now back to the machine. We do have some predefined setups. So as I mentioned, there's a few different examples that come with the template files. So if I go over to Program Manager in the HMI and the control, and I go to my workpiece folder, I see example 1, 2, and 3. Now these examples, if I go into them, they have a nice little drawing of the part file, DXF in here. They have a little drawing of what the work holding should look like, some offsets should look like, and they even give you a part program. Now, you notice example 3 just has this one PDF telling you this example is in your NC Extend folder. So we'll go into NC Extend in a little bit, but you can see you do have an example 3 in NC Extend. So there's a lot more detail in that one. That's a little bit more complex one. Now, for any one of these examples, if I come back to the 3D space, when I'm in machine and I have the toolbar popped up, I see this setup button right here in the bottom center. And when you click on setup, you'll get the examples, the setup examples that are pre-created for you. So example 1, guess what? Matches example 1 over here. So just double click on this icon. You're just going to see it's going to pop up on my table. Now, in this case, we're not actually moving the machine. This is just a preview window of what the setup's going to look like. So now click the machine button again. This lower window is going to close. And now I'm actually in physically back to the running area of the machine. All right, I can start to jog it around. I start to move around. So once I load the part and I have it sitting on the table, as long as I haven't changed anything, I can load the machine. They're using G55, so be careful with that. When you look at your different examples, I would say whatever work coordinates that one's using 56 they were using, you may want to reserve them or at least write the values down. But if we open it up, go to execute, run it like I would normally run the regular machine or Sinutrain, now I see the 3D model is going to move around and start to machine our part. Now you are physically in auto at this point, so you can completely control the motion of the machine by the overrides, by our cycle stop or our feed hold, and cycle start. So anything I can do on the actual machine, we can do here in the digital twin world. There it goes. So we can run it through. You can do mid-program starts. Now the model itself will hold at whatever state it was in. So if I abort something, right, I move away, this is what it's gonna keep. So if I start the program again, and start from the beginning, I'm not going to see it cutting anything. However, if I wanted to start back from pretty much this point, I could do that, and we could continue on cutting. So if you get like a long job and it's part of the way through and for some reason you had to abort it, it'll keep that model until I hit the reset button or I shut the machine off. So this reset workpiece is a refresh of the workpiece. So now once I click it, the blank goes back to its original. I could certainly cycle start from the beginning again. If you do a mid-program restart, like let's say I start from this pocket and you hadn't machined all that, it will absolutely work. So we'll do a program start from that point. Grabs a different tool. Yep, double NC cycle start. But of course, it thought it was a collision because the previous operation that had cleared that material is no longer there or was not there. So just be aware of that. It's not giving us a true representation unless I was literally trying to start the machine in the middle of the program on a part that hasn't had any cutting. But it is a true scenario. Little finish cut, and away it goes. Just gonna drill some holes up, doing some slotting. So you guys get it. If it sees that the tool is rapiding into the stock, it will acknowledge that as a collision. You'll see it go red. If it's in a feed move into the stock, then it's not going to acknowledge that as a collision because it is in a cutting mode. All right, good. So once we've kind of played around with this a little bit, the next step is to maybe fool around with that object, but maybe do our own setup. Now, you have full probing capabilities in here, and not only probing in auto, but probing in jog mode as well. However, the template machines did not calibrate the probes. So they gave us all the tools to be able to do it, but you do have to go in and calibrate the probe. So I'm going to kind of show you that process here real quick. They gave us a ring gauge that we can use for calibration purposes. The other thing is the machine zero of these machines is the center of the table and the top of the table. So when I go to calibrate in Z, I'm going to make sure I don't have any work coordinate loading. And with that, I'm going to come down and I'm going to datum it off the table, which will be location 0. As far as the ring gauge is concerned, you'll see there's a little print in there. It's a diameter of 60, so we're going to use that to calibrate up the probe. Oops, go back to the model. Now, to get the ring gauge up, I'm going to have to get rid of this vise, this setup. So click on the setup button again. You're going to see the previous setup. Just click X, goes away. We can double click on ring gauge, puts it in there, and now hit machine, and I'm back in the machine window. If I don't want to see the datum, I can hide it there, and we can load up our probe. So I'm just going to run over to jog, do a quick tool change, just like I was on a real machine. Cycle start, and actually the calibration process is exactly the same as if it was a real machine. I'm going to position, and now I know that the middle of this sucker happens to be sitting at, we'll do 100, maybe 200, 0, and we'll stay up from it a little bit, 10 mil. Okay. So, it's pretty good. I do not want a work coordinate activated at this point. So I'm going to go to G500, cancel it. And now I can start to jog my machine into position. So first thing I'm going to do, I always tend to do the Z length first. No reason other than just habit. This is where using those little hotkeys gets really nice because I want to make sure I don't probe into a T-slot. That would be bad, right? So I can jog my machine and make sure that I am in a pretty good position. Go over to measure workpiece, calibrate probe. Top of this surface is 0, so just leave it at length and hit cycle start. Now there is a predefined, wrong way, predefined distance, right? So when I go to calibrate, if I'm too far away, it'll tell me, hey, the probe didn't trigger. Once I get a little closer, reset that. The way our probing works is it's triggering off the collision. So it uses the detection point. It doesn't acknowledge it as a collision because it knows this is a probe, but that's how it knows to simulate the probe switch, is actually with the collision. So it's a real probing process for sure. Now you can be lazy and drive things right through other objects if you want. That's okay. In my case, I want to get this machine. I'm going to put it roughly in the middle. Oh, somewhere close, because now we're going to do our radius. So again, you can use your perspective view and say, okay, yeah, let me kind of plug this thing into the middle. Oops, went to the back. I want to be in the front. Go X, zoop, zoop, zoop. All right, once I get it roughly in the middle, now we go in. Make sure you tell it the radius, or the diameter, shall I say, is 60. If you don't remember, go over to Program Manager, go to Measuring Ring, or example 4. They gave us a nice little print. The other thing you can do, which I like to do myself, especially if I don't happen to have a fancy little print for it, we can cycle start this little, start probing, is I can go into the library and I can bring up the object. And when I bring up the object, they do give me a little scale. So I can kind of see what the size of the object looks like. So you can do some basic measurement with the scale. So I'll show you that real fast. So the probe is now set up, so I can start to use the probe. So again, go to library. You're going to find your ring gauge is right here. So if I double click on it, this is what I mean by the scale, right? I can kind of see, oh, it looks like it's about 40 millimeters thick. I look over top. Oh, yep, 30 millimeters from the center. So you can kind of get a rough idea with the scale what the size of something is as well. All right. So what we want to do is we want to now start to kind of show you how I can use this to set up a job, right? So what we're going to do is we're going to use the setup they have, and we're just going to set a basic 0. But we are going to do it to a work coordinate that we know they haven't used. And then we're going to write a little program, right? So I just want to come in, set up, and then we'll just do some simple toolpath and show you how we can start to really do kind of anything that we want to do within this model space. So I jump over, go back to setup. I'm going to get rid of the ring gauge by hitting the X. I'll pick example 1. Now in their case on 55 it was offset. It was some other location. But mine, I'm going to create a brand new 0, and I'm going to do it based on G505, let's say. So I type it in, bring my Z down, get kind of close. Oops, a little too close. All right, so get it in position. I want to be roughly in the center. That's actually not too bad. It probably will have enough for probing to get that part. And now set it up like you'd set a normal job, right? I want to pick my Z. What do I want the top to be? Maybe I'm not going to face it. We'll leave it at 0. Cycle start, measures that surface. Now I go back. Maybe I'm going to measure the 4 sides of a spigot. If you were to go to look at the print, you would notice this is 150 by 100. So I can just type in those values. I'm in metric just because the default machine was in metric. I could certainly switch this machine to inch and still drive everything as if it was, an inch machine. So that's no problem. Search distance 10 mil, probably enough. Maybe go just a little bit more to be on safe side. And then what do I want to consider the center? 0, 0. So here we can use any of our measuring cycles. You can even make custom measuring cycles. Anything you can do on the machine, you can literally do here inside the software. It was hard for me in the first because I was so used to Sinutrain and such a big advocate of Sinutrain, having promoted it for so long, that I was like, yeah, sure, my virtual machine, I don't know. But once I saw what it's capable in this, it's next level. I mean, literally, everything I would do on the floor, I can do here. Okay, so we got a little part set up. Jogger out of the way. When it comes to programming, yeah, just go in and start writing programs. So I'll make a quick little shop mill program, and maybe we want to just, I don't know, mill pocket, square it up, something like that. So set up your dimensions, right? Like I normally would. Probably more like 50 mil on the thickness. Where do I go when I'm done? Safety, this is all the same. You guys have watched plenty of my webinars, and if you haven't seen shop mill programming, check out one of the webinars we've already done, one of the many. But yeah, I mean, maybe I want to come and toss a pocket. Now, there is a complete tool library pre-created, so you can certainly use those. I'm going to show you in a little bit how to actually create custom tools and all that good stuff. Oh, I want to do a circular pocket, I said. So let me redo that. I'm chatting away and I'm not paying attention to what I'm doing. I'll just throw some quick numbers in here just so you guys can see something happen. So maybe we're doing a 50 mil diameter, 10 mil deep. We'll do a 50% step over, take it in 2 cuts, and we're going to just feed right into this puppy. Sure. So that's going to mill my pocket. Maybe I'm going to come in and do a, multi-edge spigot. We'll do the same feeds. Center 0, 0. I know the width is 100 by 150. Maybe we'll go to 90 by 140, take 10 mil off of it. I'll give it a little corner break, make it look pretty. We'll go 10 mil deep, do it in 2 cuts. Right, so whatever you create, you still have full simulation here. You can do everything that you're used to at the control or from Sinutrain for argument's sake. But the difference here, make this 100% so you see it move, is once I've proved this out, here I don't really have a good concept of what the machine motion is going to look like, especially when we get to more advanced machines like 5-axis machines, right? So I prove it out here, I come out, I go to execute. Voila, we're running a job. And it's using that new 0 that we created, that we found. I could position this vise anywhere in space, take that probe, go measure it like I would measure the real part. And the more accurate they build this model to your real machine, I mean, I've built one for my fryer mill I have here in my studio, and literally the offsets I measure in here, it's the same over the machine. I could literally just type the numbers in. I mean, it can be that accurate. It's amazing. All right, so you guys know what this stuff looks like. We can shut her down, maybe I'll jog away. So that's all fun, but we want to get to the cooler stuff, right? We want to get to the area where we can start bringing in our own work holding, right? Our own programs, our own vices, all that good stuff. So there's a couple ways to do this. I'm going to show you first doing it from simple STLs. Generally, you go to most work holding manufacturers, they'll actually publish models of all their work holding. In this case, we happen to use a Kurt Weiss. Now, when it comes to creating your blanks, your stock, you will need to have access to some kind of a CAD system. So you can't generate any STLs here in the software. You have to pre-create them. So especially when it comes to stock, you will need access to some basic CAD system, whether it's a CAM package you're using to do some basic CAD. I don't know if I've ever seen any CAD or CAM system that couldn't create an STL. It's a pretty basic, primitive 3D object. But what's going to happen is I pull down these files, and then I'm going to want to drop them into what we consider our virtual CF card. So we call it a CF card because in the real machine, you have a physical CF card in the machine. Here you have a virtual one. Now, you don't actually have to copy and paste into this folder directory I'm showing you. When we go to use them, we can just browse to them and read them in. The only downfall is if I do that, I won't have the source STL file that gets copied with the VCP file. So if I want my users, or if I want to make sure that me later, when I go back to this VCP file, this specific machine, if I want to have the source STLs that I built up the stock with and the work holding with, you want to copy them to this folder. If not, when it comes time to bring them in, you can just browse to them, because the next step is this little interface screen you see here. And this is where I kind of put the whole thing together. We assemble all our objects, we plug them in. Once we've plugged them all in, then we can physically drop it on the machine table. We can move it around. We can put multiples in. I can have multiple vices like you see on the right. So here we can start to customize the setup to anything we want. So let's do it. I mean, that's really where the rubber hits the road, right? So let's come on in. We're going to get rid of our little example one sample, and we're going to import a machine. So it's good when we're not import some work holding. Now it is good habit to get into when you're going to do anything on your setups to remove the one that's on the table, because at some point you're going to be putting a new one on, but also you can't edit the one that's already mounted to the machine. So if you're always getting the habit of removing the setup before you make any changes, keeps you from getting an alarm telling you, hey, you're trying to manipulate the setup that's already loaded. Come over to library. And what we're going to do is we're going to use these icons on the bottom. Now, you see how you have a little like rectangle with a dark area and a light area, like the yin and the yang sign, and then you have a little object below it. And then to the right, you just get the one box or this little what looks like a clamp. So this is your stock. Obviously, there's a stock below it. This is a representation of your work holding. We call them protection areas, but it's your clamping. And then this is the assembly of everything. Now you don't actually have to use these other two icons if you don't want to. What I do is I build everything up in the setup, and then this way when it creates the setup, and I'll see you have the little icons with some of them are just blank, some are all together. This is a setup. This is just the vise. This is just the blank. Well, when I build the setup, it makes these other ones for me automatically. So in this case, I just go right to setup and it pops up this little subscreen. Now, with this screen, there's two methods. First one I'm going to show you is the STLs. Later, I'm going to show you how to use a step file, an STP file. But first, I want to bring in, now you can bring in any order you want. A lot of times I like to bring in my work holding first, and then I bring in my stock second, because that's kind of how I would build it on the physical machine. Now you have the ability of importing an STL to your CF card or the library. Now, what I haven't done yet is I haven't dropped any files in there. So why don't I do that first? So in this case, I'm going to use my little CF card button. It pops up a window, and where I want to place my models is under the user folder, CNCMILLING, and then go into the 3D folder. So this is the area I want to drop any STLs that I want to have kind of carry with the VCP file. So I have a bunch of them sitting on my USB stick under this little webinar folder. So here's my work holding. So I have a bunch of STLs. I'm going to grab them all in one shot. I'm going to copy them, and I'm just going to go right back to that 3D folder and paste them in here. Once they're pasted in there, then what you're going to notice is when I go back to the setup, if I click on import, it's going to automatically show me this folder and show me those files. Had I hit that button before, I wouldn't have seen anything there. I still could have browsed, absolutely, could have browsed to these. There it is. I could have picked that component at that time and said open, and it would have built it, and it would be there, and it'd be in my library. But again, I just wouldn't have the STL file as far as the VCP file. So it's really kind of up to you. In my case, I am going to do it this way. So I'm going to work from the body. Now I broke up my Kurt to two pieces, the body and the jaw. And the reason why I do that is it allows me to then move around. I can bring in the next component. Now once you have one, you're going to use either the plus or the arrow. The arrow is your library. So you have to have it already in your library to go there. Or I can go right to my card again or my models. So you notice I bring them both in, and now I have my Kurt vise and my jaw, and I have it closed. So the reason why I did that is I can go to this little offset icon, and I can now adjust my vise position, my jaw position, to whatever my stock width's going to be. So it keeps me from having to make a whole bunch of separate work holdings. I can just keep using this vise over and over again, and just moving my jaw around. Now, one of the things you're going to want to try to do, it's going to minimize the amount of moving around in space you have to put this vise, is you're going to want to have a pre-defined location on the vise as your zero datum. So mine is this one right here. It's the bottom center. If you're familiar with a Kurt vise, there's usually a reamed hole right there. If you were to put it on a fixture so you could rotate it, that's my 0 point. And that 0 point will then connect to a predefined location that was set up on the table of that machine when they built it. And then from there, I can still use these offsets if I don't like where it is to move it around in space. There's a couple different ways to do it. So we got our vise, we have our jaw set. Now I'm going to bring in my stock. So the stock again is an STL. So I come over, I go to, in this case, I'm using my little 76mm square stock, open. Now that's going to drop in, but however, this one, I had my 0 in the top center of the stock, and you see it's aligning them both. So now I would just use my offset to start moving around the stock. Now from me, and I have a little cheat sheet here, I think, where are you? Yeah, right back here. So I want to say, yeah, it's 22 by 180, puts me exactly where I want. A lot of times with this, I just start plugging in some numbers until I start to get it where I want it to be. Certainly, if I knew the exact dimension from the top of that jaw to the bottom of that vise, and I knew the exact dimension of this block, makes it kind of super easy. I can just plug in the numbers, do a little simple math. But I'm just using this little offset to type in the value. I want to shift it, and the direction is going to be plus or minus, and eventually I get it kind of stuck where I want. So once I have this all set up, now I'm just going to give it a unique name. And it does have to be a unique name. I can't use the same name as something else in the library because this will now be available to me. So I'm calling this my Kurt Setup 1. Click Save, and now you're going to see not only do we get the Kurt Setup 1 with the double icon, but I also get the jaw, the body, and the stock. And now, since these are all in my library, I could independently use any of these for further jobs, and I could just make setups over and over. Say if I use this blank a lot, but maybe I go to a self-centering vise, or I don't know, a different model, a D88 vise, whatever it is, I could just grab that and reuse it. So it kind of keeps you from having to have a lot of the same models over and over again. Now, when it comes to installing it on the machine, you're doing it the exact same way. I go to machine, I click setup, and once you've built the setup, it then pops up in your library. So it comes into the library, I see it, I hit machine, it's now here. Now, if I wanted to move where that vise is on the table, there's a couple methods. So first, normally what I would do is I would come into this setup, and then I would change my placement to my machine, my MP position. My mounting point position is what it stands for. Now, at this scenario, like maybe I want to move my X 400 millimeters over. What you are going to notice is I have to do it for every single component, but I can, eventually slide it all over, and now you see my vise is, I didn't hit save, blockhead. All right, hit save, now everything's saved, and now you see my vise is shifted. So that's one method, but let's say I had 5, 6, 7, who knows how many components in this setup assembly. It doesn't necessarily have to be 3. That can be a little more difficult. So what we have here, get back to it, is there is a way to create what's called a mounting point, an association between the objects. So what I like to do when I do this is I choose kind of a master item, and that's going to be the object I'm moving. And then I link with this MP linking kind of functionality, I link the objects together. This now allows me to move one number and all the rest of the objects will follow. So this is super handy. I bet you Bruce is looking at this going, why didn't he show me this months ago? Honestly, Bruce, it's because I didn't know about it months ago. So I'm going to cancel that. We're going to just put those back to 0, but I'm going to show you how to do it the other way. Okay. It's amazing when I get prepared for these little events, how much I I learn about things that I just kind of did the long way forever. So if you go back to your setup, and as I mentioned, I'm going to want my body in this case. I want whatever is kind of carrying everything else to be my master. So I'm not going to go into the body, but I'm going to go into both the jaw and the stock. I'm going to click my little offset button like before, but now I'm going to use this little square with the circle. This is how I create mounting points or connection points. What is that? Oh, I don't want to be in the body. I want to be in jaw. Oh, remember I told you, get in the habit of removing the object before you manipulate it. It's not letting me change it because it's still associated, it's sitting on the machine. So I can't have it on the table when I go to do this. So open it back up, click on the little offset, and now you'll see I can click on this little mounting point. So all I'm doing is I'm associating the jaw with the body by clicking that little indicator. And save it. And now do the same thing in the stock. So go to this little icon, and now I want to link it to the body. I want everything linked, in this case, to that one common item, my body. So once it's all been saved, save the overall model. So now when I drop it on the machine, plug it on the machine, oops, I just need to pick, I still want to go to MP position, but I just picked the body, and since everything's associated to the body, and you see one number, the whole thing moved. So just, you know, 3 items, is it that big a deal? No. But, you know, you could have sub-assemblies here that could have a lot of components, and that could save you quite a bit of time. So you use that little MP linking trick, and everything will now move together as one. Now just be careful here, because if you pick the non-linked component, it'll still move like it did before. So you see how I got that independent move? So it's up to me, and if I left that there, I don't know if I ever tried this, and then I move this, yeah, they'll all start going, right? Because they are still all linked. So just keep that in mind. You don't want to move you want to move the master, right? Call it the master. You don't want to move the other ones, what you linked to. All right, so we'll put it right back center of the table. And that's that mounting point I mentioned. You know, that's predefined by the guy that builds this model, where he wants the default point of wherever your 0 on your primary component is, where would it drop? In this case, they usually set that to be the middle of the table, is pretty common. All right. We're moving right along here. I'm going to do it on time, not too bad. A few other things we're going to show you guys. So now we're going to go in and we're going to drop in a part program. Now, when I want to bring in a part program, certainly I could use a USB device and bring it in that way. However, I can also use, as long as it's been set up, the NC extend folder. And in that case, I'm going to navigate to this path with the CF card. So user, sinumeric, data, prog for program. So from there, we can copy and paste. And once I drop it in, then you'll see the part program will be available to me in NC. We try to keep these machines kind of like, you know, kind of like their own little island or your little sandbox, right? They're their own entity, separate from everything else that's going on your PC. So when it comes to moving things in and out, it can be a little tricky. You can't just browse to this machine from your normal Windows Explorer. You have to get to it through this utility, and then you can push things in and out. What's nice about it though is you're playing with different machines. You can't affect one that wasn't running, right? You'd have to be into it because they're all kind of separate. They're their own little sandboxes, I like to say. So we're going to bring the file over. Once we've dropped the file in, then we're going to create some tools. Now here, I'll same rules apply as working with devices. I'm going to myself drop some STLs into the directory. You could just browse to them at the time. It's totally up to you. They could be external. But one of the things I do want to point out when you start to import tools, now you're going to grab these tools just from any of your common tool suppliers. These tools, I think I got them from Seco, is either Seco or Kennametal. You know, all the good tooling manufacturers have STL or have CAD files, shall I say, not necessarily STLs, but CAD files available for download. Generally, depending on the format, you might have to open it up in your CAD system and export it as an STL if you can't directly download it as one. But you also want to verify where the datum of the tool is. So the tool 0, you see that with this little UCS in the picture, should be at what we call gauge line. So on a Cat 40 tool, it's going to be about 1/8 of an inch off the top of the flange is gauge line, and it's going to be dead center. It doesn't matter which direction X and Y point in, as long as your zero's in the middle of it, and in the Z, it's right at this gauge line point, that'll give you the correct connection point in the machine. And once we have it all said and done, we're going to come in, we're going to zero out this block real quick, and we're going to cut apart. And you're going to get to see the entire process in one whole snapshot, shall I say. All right. So step 1, let's get a part program in there. Currently, if I go to NC Extend, you notice I don't have any files in there. I'm going to change my focus. I'm going to drop into that folder and then I'll go back. If I didn't, you wouldn't initially see the file. I might have to, move directories and come back in, but it's just a refreshing thing. Pick your CF card. Now you're still going to go to user. You're always going to go to Sinumeric, but now instead of going to 3D, you go to data and program. So there you see the folder that it was visible in NC Extend. Now I can come on down to wherever my part programs are. So I have one there. I'm going to copy that, bring it on back, and I'm going to drop it right here. So now it'll be visible if I was to come back to NC Extend. There it is. There's my part program. Came out of my NX seat and allows me to do this nice little job, right? Additionally, I want to get my tool holders in so I can use them when we go to setup. So I'm going to put them in that 3D folder as well. So user, Sinumeric, 3D, this is where I'm going to drop them. So I have a bunch of pre-created STL files. Let me go back into my little USB stick. Here's my tools. So I got a nice little example. So we got a couple different ER collets, some solid end mill holders, right? Now, the naming terminology you see here, this was not directly given to me by the holder manufacturer. So I kind of came up with this on my own. So I like to certainly call out the ER collet size. That's important to me. The taper type, especially if I'm managing a lot of different tapers of machines. And then my projection distance. So that would be the distance from gauge line to the very end of the holder. So that helps me when I'm thinking of my projection for my tools. And then this way, whenever I come back, I can say, okay, well, here I got a solid end mill holder, SM, for 3/8 tool, and I know it's got a 2-inch projection. So let's drop this back in 3D. You are not allowed to put these in subfolders, so everything has to just sit in the 3D folder. Just be aware of that. So close it, and then later, when we go to build the tools, we'll have the holders available to us. Now, what you see here, this is what we call our little fast protection mode. So this is not an STL file. This was, what was done, was when they built this tool, they used this fast protection mode here. And that gives you just a quick little kind of box representation of roughly what the holder would be. Now the diameter of this, if you are going to play with these, that is set up in the settings area with the gear right here. So that would be the diameter, and it will use this diameter at the time of creation. So if you change the diameter, it won't go back and affect previous tools you've built. So you can actually build them with different diameters, but it would then stay for new tools until you change it. So that's certainly one way to start to create tools. So I'm doing all this with the little toolbox button as opposed to the setup button. What we're going to do is we're going to make some STLs. So let's build some tools. I'm going to go into my program. Now I'm going to change the work offset. Let's see, right now we're using G54. So I want to change G54, and we're going to do is later we're going to set up G505, right? Because I don't want to mess up a work coordinate that might be being used by another job. Okay. Other than that, I want to grab my tools. We're going to build up my tools. Now, when it comes to some of the tools, right, you certainly don't have to link STLs and all that stuff. You can just kind of build them up as you normally would. Now, when it comes to facing tools, for argument's sake, I can build it as I normally would, right? So give it some projection length, give it a radius. This one is 25.4, some number of flutes. I can go in and go to my further data, give it, some overall size and an angle. This will all still work in the simulation area. However, if I tool change this tool, you will notice that currently we don't have full graphical support for facing tools. So it's just going to use the critical diameter in this case. Let me zoom it out. So see how it looks like a simple square. I could go in and do a fast protection if I wanted to get some kind of a holder on this. So the tool that's in my spindle is always this first location. And then the rest of these tools, I can scroll back and forth just by holding my mouse button, my left mouse down and dragging it. But the numbers you see is the turret location, or the tool changer location, the pot location of the tool. So if I wanted a fast protection on this one, and I wanted the outside diameter obviously a little bigger than my OD diameter, I can still give it a little length, give it a little projection, and you hit apply, and it's now going to drop that little box on there, right? Give me a little bit more of a graphical. What we want to do is we want to get a little more elaborate than that. So we're going to now build up the other tools. So I'm just going to search down to my next tool. Happens to be an end mill 3/8 inch. So now let's go build that tool. Obviously, the creating of the tools is no different than doing it on my machine or do it in other versions of software. None of that's changing. Really, the big trick here is just working with the 3D at this point. 8 times 25.4. Just do a quick little conversion since I happen to be in metric. So I'm going to build up the tools real fast, and then we're going to add our holders to them. Just do a quick search, get to the next one. Oh, next one is 3/16. Jump back in, new tool, end mill. Certainly I could have changed the machine to work in diameters. I'm just working off the template machine, right? You can, bring up your calculator, do whatever you would normally do, right? So there's my 3/16 divided by 2 times 25.4. There's my radius of that tool. And then my final tool is a chamfer mill. So I'm going to show you how to create the chamfer mill as a tapered end mill, as opposed to, a lot of times we cheat and just use a center drill for a chamfer mill. But if I really want to have a controlled bottom flat, I can build it that way. So normally, like I said, a lot of times I'll do center drill for a quick chamfer mill. But if you do a bevel cutter, this is your tapered end mill. So here We can do this as our chamfer tool. Now, the trick there, give it some rough projection. Oops. The trick here is this diameter. This happens to be or in this case radius, but this would be the size at the tip of the tool. We need to know that if you're using Keter comp, because that's what we would comp. So I give it that size. So let's say for argument's sake, it's pretty small, 0.5 millimeters, right? Some flutes if I was doing feet per tooth. Now when you go to further data, now we're going to give it the actual shank size of the tool. So 0.250 times 25.4, that's 6.3, and the angle, and this would be the angle of one side, so not the full included angle. So if it's a 90 degree, it's half that. If it's an 82 degrees, it's half that, right? Whatever the angle is on the one side. But this will now build up a chamfer mill. Now, once the tools are created in the library, if I hit this tool icon again, they're now going to show up, and they're going to show up with a little red to them because they're underdefined. You could also filter everything down by unchecking that and just showing what ones are underdefined. So that just means that I haven't done any additional definition as far as fast protection or a detailed holder. So let me go back down to them. So in this case, I have my 3/8 end mill, so click on it. And what we're going to do is we're going to set up our detail protection. This allows me to physically bring in the STL file. So edit assembly. First thing is the flute length, right? So this is your cut length. So maybe I know that this tool can do approximately an inch, right? 25 mil. And now hit edit assembly. And what you'll see is you see how they have the two different color contrasts. So this was driven by that value I just input. And then the overall length is coming directly from the tool table. So as I start to insert this into a holder, if it's not sticking out far enough, I have to increase the length in my offset table. I don't have any tools yet in my library. They're just sitting on my SCF card. So do an import STL like we did earlier. And now you see the tools came into this area. So I got a solid end mill, 2-inch projection. So 100 mil overall, roughly 4 should be okay. Say okay, and it immediately pops up, shows you what it's going to look like. From this point, just hit save changes. Now, if you think this projection's too much, like I mentioned, you can come in here and it's driven by that length. So see how it updates? Just make sure that when you play around with it, you're not editing it. So you don't want to be in here when you try to change that, or it's going to give you an alarm. See how it gave me an alarm and it never actually took. So be careful of that. You want to make sure you've saved it before you make any changes to the tool projection, or it may or may not take. So it's really that simple. I mean, there's not a whole lot when it starts to defining and bringing these holders in, as long as I have that 0 right? The datum's got to be right there. So as we load it into the spindle, you'll see it'll be in the right spot. Now this tool, now we're going to do the 3/16 tool. You know, maybe I want my cut length to be a little smaller, and maybe I'm going to use a collet chuck for that. So you come in, I'm going to use a long projection. Here I got a 6-inch long collet chuck, a little ER16. Now you'll notice, where did my tool go? Tool's in there. Remember, the 100 mil is from gauge line to the tool tip. So if I need it to project out, I'm going to have to take into account this overall length plus that projection. So if I save it and I now start to increase a little more, there it goes. See now it's updating. So 200 is probably more than enough. So just keep that in mind. This length is always from the spindle face to the tip of the tool, not necessarily just what the tool is inside of your holder. right? You're used to grab an end mill off the rack. What's the overall length of the end mill? That length isn't just the end mill, it's the stack of all the components combined. Get into our chamfer mill. Now the chamfer looks funny in this little graphical window, but as we come in, and we'll make this small, maybe 10 mil. As we come in, you'll see I get a much better representation, edit, when I actually come into this window right here. So there's your 45 or your included 90. There's our little flat and our true outside diameter. Same scenario would apply as far as the overall length. So, if I'm using a 4-inch projection, which is roughly 100 mil, you're going to notice my tip is right about even with the face of the collet. So just save it. And now we can adjust. Maybe I'll go 120. Now I can adjust and get whatever projection, but you do want to try to mimic what you're going to have down on the floor, right? Because if I'm looking at holder avoidance or holder collisions, I need to have all those projections be what's going to match the real world scenario. So we have some tools set. We have our part on the table. I just got to do a quick 0 there in 505. So I'm going to do, similar to what we saw in my previous setup. I'm going to go grab my probe, load it up. Now, in this case, I'm going to position somewhere close. So I'm going to tell it to go rapid 0, 0, maybe 100 mil. If I collide, not the end of the world, not so bad. All right, so we're going to jog down. Oops, a little fast. All right, get it right above the surface. Good. My X looks okay, but my Y, I'm going to have to move back. So go plus, roughly ballpark in the center. And now we just measure as we normally would, right? Make sure I'm using the appropriate work offset. I've already loaded 505, so we'll find the top of our part. Now, if I wanted to take a little cut, maybe I'll tell it I got a little bit of material at the top. I can do that. Just exactly what you would normally do on the floor. Okay. We'll measure, quick little measure. Got a lot of questions. This is awesome. So we're just about at the end of the content. I know this was a long one, but there's a lot of detail to this. So I will be going through. I'll stay a little late for those of you guys that can hang out. And if you can't, I'm going to get to your question anyway. Check out the recording. I'll obviously have the Q&A section caught on the recording. All right, so there we go. So we've set up a job. We're ready to run. So I go over to my program. There's my little setup. We go execute. Oops. Cycle start. Starts to run the program. Now in this case, boom. My look ahead says I got a problem, right? So this machine, remember, machine 0 is the top center of the table. However, the post was assuming that my machine 0 was somewhere probably up in space. So to make this part work, I will have to update the home positions. So I'm just going to do a find and replace because I know these exist in a couple places. And I'm in this case going to tell my machine I want it to reference to 0, which is the center of the table. Maybe a small positive value, maybe like 100 mil off, so we're loading station. And I'm going to guess I can get to 500 millimeters in the plus. Let's see if that works. So replace all. Yep, got them all. So now we've just updated our home position. Now we go run. And there you go. She's now in and she's cutting our part. Oop, oop. Zoom in a little bit, take 2 cuts. I can certainly, move around my graphic window while it's running. You see, it's really not laggy at all. I mean, it's It's quite amazing. Now, what I will tell you is this software really runs well when you have first a full-blown graphics card. I have an NVIDIA card in this. This is a workstation, and you want to have at least an i7. You want to have a pretty decent performing CPU. This software would certainly be more demanding on your PC than Sinutrain would be. But with that being said, if you got some horsepower, boy, it runs really good. So we can just keep on going there. Now there's some cool functions. I don't have time to go into it in detail, but there's the save in process setup. So I can actually save the machine state of this object. So if I wanted to use that as my secondary op stock, I could do that. But what we do want to show you how to do before we start taking questions is how to import from a STP file, because that's pretty cool. So I'm going to shut this down. You guys have seen plenty of machines run before, because I want to show you the STP section. So the last thing we're going to do is we're going to now build up this little setup that we pulled right out of our CAD system. And this has a bunch of different subcomponents. So what I did was I went in, I pulled out the workpiece and my fixturing, and I built a step file of that object. Once you have the step file, I come into this little utility and it allows me to kind of pick what's the stock, what's the work holding. I can move my datum around here. It's really, really quite slick. So let's take a quick peek at how that works. So I'm going to build a new setup. So we can get rid of that setup for now. Go over to the library and we're going to do new setup. Now, before I was using these buttons right here, right? Pulling from an STL or maybe the library if they're in the library. If you use the top button, now it allows me the ability of browsing to that file. So wherever it is, here I got a step file. This is my little step file I pre-created, but this is my work holding. So open up your step file, and it brings up this little utility. Now what I will say, which might even graphically for you guys, that's pretty good. I guess that looks pretty good on the screen. So you have this little utility. What's cool with this little box is it changes your perspective, right? If I want to look at it from an angle, I want to look at it from the top. So I could rotate with my mouse, or I can just use this little box to move some things around. So I thought that was kind of cool. We're going to go on the front. All right. So what I want to do is I want to be able to kind of grab the object. So what we give you is now a nice little tree, and this is a tree of all the components and subcomponents that make up this part, right? This assembly. So if you uncheck them all, everything just goes kind of translucent. So now I can click on different objects to see. So this is some kind of a hidden object. I don't need that. The suspension bracket stock is obviously my stock. And then as I pick some of the others, you see it gives me some of my work holding. So the ways it's going to work is click on the components that you want. In this case, I want my stock. And I'm going to say, hey, add the selected item, whatever's checked here, boom, add that in. You could rename it if you want. I'm just going to leave it the same name. And now I want to add my protection area for my work holding. So pick the components that are relative to the work holding. Once I've picked them all, click on Add Selection, and there they are. Now, I might not know where the 0 is. I don't have a reference initially, but maybe I want the 0 to be the center of this lower point for the connection point. So click on your little offset icon again. But the difference here is not only can I type things here, but I can come in and I can pick different objects. And once I pick it, it gives me a nice little example of where my unit coordinate system is relative to that position. You can Pick any point in space that I want to pick. So I'm going to go grab that position. So that should be my 0 location. Once you've clicked it, now I can hit import. That should be it. Let's try it. So it brings it over to this area. I get a nice little datum verifying that it grabbed the 0 that I wanted. All right, I see blue is Z, so that's up in here somewhere. I see X is red, and then I can move things around if I wanted to in this point. But if I'm happy, and you can see that was only a couple clicks, I'm going to call this my STP one, save it. It's now in my library right there. I get my block, I get my setup, I get, if I look here, there you go, there's my work holding. So now I could reuse this one. Now it's in my library. And as far as the machine's concerned, I can now drop it on just like I dropped the other ones on. Move it around, do anything I want. So really, if you start to get into a lot of these more complex assemblies of your work holding and your stock, I think the step file is certainly the way to go. Okay, I think there's a lot of content there. Man, I do these slides and I always think, oh, this is going to be more than an hour. So the last slide I put together for you, just to give you an idea of kind of where we can go for here. Obviously, we did this around a simple 3-axis mill, but you get to 5-axis, we can do nested vices like these Raptor vices, turning, all your different work holding scenarios and turning, 4th axis, multi-clamping on tables. I mean, pretty much you dream it up. This software can support it for sure. But we want to take some questions. So with that being said, I see a ton of questions here, so let me start banging through them. And if I miss your question, I apologize. You can always reach out to me. You got my email address. There you go. Boom, boom, boom. So Dave asked, is the software compatible with an 840? So that's a good question. So right now it's more of a marketing or a commercial question, really. You can physically build an 840 in this software. Things that you're going to run into problems with is the PLC is not importable. I can build, like I would in Sinutrain, a machine off of the NC file, but I would need to have some default PLC to drive the rest of the behavior. So it's not super easy, but it is possible. Like I showed you that previous screen, and let me go back to it. On the left, that's our DMU50. This is the one we own that's in our training facility. That's an 840. I built it from there, but you do have to do a little manhandling. So the current market answer is not yet, but my guess is we're probably going to start marketing the software to support 840 as well to get these advanced 3D capabilities. Is there a mill turn template? I want to say yes, but I don't believe there isn't one with a B axis yet, but it can support it. Does it work with a touchscreen? Absolutely. You can certainly do everything I'm doing with the mouse. If I had a touchscreen here, I could do it with a touchscreen. Can we save our screen layout? Not so sure. I'm 100% sure what he's referring to. I can save the in-process workpiece, as I mentioned, but I don't know what else. Mike will have to reach out to me later. Can you recreate our own hotkeys? I don't think so. I'm pretty sure the hotkeys are fixed. You said a 3D mouse. Do you mean a 3D Conic Spaceball? Yes. So currently we're not supporting the 3D Spaceball style mouse, but hopefully we will in the very near future. Can I create split views? No, it's only a single view, so you just have the one window. All right. Is there a measuring tool to ping the raw material rather than guessing where to position it in the vise. I'm assuming he's referring to when I positioned it in the portion when I set up where I made the initial setup. So there aren't any other tools. You're going to use your offsets really to drive it. More likely, you probably built this externally, and I just grabbed the numbers so I know how high it's going to sit up and kind of where it is, and I can just type it there. You can also have built the STL file to be in the current position, and then I don't have to move the object around at all. I just like to have universal datums like I did with that stock so I could reuse this stock over and over again. Okay, I think that's a lot of ones on the chat, so let's go get over to the Q&A. So run my VNCK. Is it going to migrate to FlexLM from the current MAC address USB licensing as cybersecurity is moving away from USB? Yes. So this software, and I want to say it's the same with the VNCK variant, although I haven't set up the VNCK version myself, does use the FlexLM style licensing just like NX. So there is no more USB and encrypted file like we had in Sinutrain. It will be a license that sits in your LM Tools manager. How is this going to work from the machine tool builder side for digital commissioning of the control to create the VCP file? New form of SRAM, as this should be purchased when you buy the machine. As I hear, machine tool builders are just promoting their Powerline solution line forward without doing the digital commissioning. So, the perfect world certainly is that the OEM is going to use this tool in the create version, the create my virtual machine, as part of his engineering process, right? What it allows you to do is, you can take your models right out of engineering, you can start piecing together. I can start working on the NC commissioning and even debugging of the PLC before I start casting the first part. Now, certainly it's going to take OEMs a while to come over to this process because it is a process change. But the concept is if they use the software to design the machine and build the machine, at the end, they automatically get a VSCP file that they also then can sell to the end customer. So it's a whole new value stream, really, of being able to now not only make your manufacturing process more proficient from an OEM side, but you also now can sell the digital twin to the end customer. And believe it or not, more and more guys are really following that process. So this isn't an anomaly. We have a lot of OEMs that see it. It makes sense to them. They're able to reduce their time to market, and they're starting to go this route. But it is going to take time for sure. As I see you're creating a project from a template, this does not align with what we would purchase with a machine, as I assume all options would be available, but I don't see where custom options from the machine tool builder would be there. Hence, while you may be accessing the kernel, I don't see it aligning with the actual machine. So again, the machine tool builder is going to provide you the VCP file, right? So how his machine is commissioned is going to be how it looks here. Like for argument's sake, Track Machine Tools, we're doing a ton with Track Machine Tools. They are commissioning their machines completely digitally. And then they're selling the digital twin with their machine. So they have custom screens, they're going to be here. I mean, exactly the way that machine looks in the real world is how it's going to be. So I'm showing you a template machine just as a simple example of how to use the software. But yes, you will buy the VCP file from the OEM. That is the intention here. Confirming this is touchscreen compatible for training purpose. Yes, it is. Are we able to save screen layouts besides the reset option? Paul, I need more information there. I'm not 100% sure what layout you'd like to save. Can you hide the machine outer framing? Probably asked that question before I showed it. Yes, with the toggles. Is there clear out collisions after the VCP file grows into a monster? Yes, this is true. So you want to, the collisions will stay. You know, if you want to keep saving your collisions, it'll keep building, but it will make the file pretty large. So I would say get in the habit of clearing out your collisions from time to time. Is there going to be a calibration of a sphere added as a default option? So the sphere is already there, right? I could have, let me just show you guys real fast. Paul is asking when I go to calibrate, let's go on to jog. Back out of here, we have an option for a sphere. If I had built a sphere and it was on my table, I could absolutely calibrate to a sphere. I just calibrated to a ring because that was what was in this machine. But I could have made my tooling ball sphere as an STL, dropped it in the table, put it in position, and calibrated my probe that way. For sure, that would work. Okay. A few of the main prerequisites of the theoretical digital twin are time, the real assets, physical data acquiring to get the adaptive model to change according to the change of the real asset, and closed loop systems where you can, okay, but I'm not seeing the question. All right. How can we approach this with Siemens digitalization? Oh, maybe that's the question. So I would say reach out to me. Why don't we take this offline and we can certainly dig into this a little deeper. All right. If you include a spigot at the start of your program, it makes the top of the part 0, but I want to be 20 thou. How to do that? So that's in the settings of the measuring cycle. So Bruce, we could take that offline and I could show you how to do that. Do STP files have to be millimeters? No. So we can support the step file or the STL files in either unit of measure. So that's okay. I think earlier versions of software, you wanted to make sure your STLs matched whatever unit of measure the machine was built in. That is no longer an issue for quite a few versions. Oh, the layout, this is from Paul. The layout was when you were changing the layout, moving the window around. It was about 9 minutes into your session. Oh, I think he's referring to, get back to it, the layout of these windows, right? I don't know of a way of creating a custom layout. Now, what I will say is once you move these around, when I come out of the machine, right? So let's say I moved, and I always wanted my 3D to be on the right side, right? And this was my layout, preferred layout. Once I close the machine by switching it off with the red button, and then I hit, you're going to see there's going to be a save icon. I hit the save button. So that's saving the project to the VCP file. So you do want to make sure you save it. If you don't save it, it's going to lose everything you did in the last session. But the next time I power this up, it's going to power it up based on that configuration. So I guess to your point, you can modify the layout any way you want. You just can't have like a library of layouts. It's just going to hold the way you left it the last time. But you know, if I come out of this thing and then later on I relaunch this project, it's going to relaunch the project based on the layout the way I had left it. Wow, that was a ton of questions. So I probably missed some. I was bouncing back and forth between a couple different windows. I do want to thank everybody for hanging on. We went a little over, but I think you guys probably got some value out of it. So again, appreciate it and look forward to seeing you in the future. If you guys have any questions, don't hesitate. You can always reach out to myself. Again, there's my contact information. But have yourself a great weekend, and we'll make sure we get the recording out to you as well. So thanks again.